Hi guys, here's your video on 5.5, the multiple angle and product to sum formulas. So the first thing we're going to look at are double angle formulas. So I have sine of 2 theta equals 2 sine theta cosine theta. Tangent of 2 theta equals 2 tangent of theta over 1 minus tangent squared of theta. And cosine of 2 theta has three options. So when you're working with cosine of 2 theta, you can pick and choose between which of those options you want to use. Now, since we are using a bunch of formulas, I would recommend that you have your formula sheet out right next to you as you're working through the notes and on the homework assignment. Okay, so first thing we're going to do is a double angle formula. So find the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta, given that cotangent of theta is 4/3 and theta is in between pi and 3 pi over 2. So these two pieces of information are going to help us draw a triangle since I don't actually know what the angle is. So I do need to pick the appropriate quadrant. So pi and 3 pi over 2, well, pi is over here, 3 pi over 2 is down here, so that angle is in this third quadrant. And it says that cotangent is 4 over 3, which means that tangent is 3 over 4. Tangent is my opposite over my adjacent, so here's your angle. Opposite side is 3, adjacent side is 4, but pay attention to the quadrant that you're in because we are in the third quadrant, which makes both of those negative. And then I can use the Pythagorean theorem to solve for that third side. Third side is 5. Okay, so now I'm going to do sine of 2 theta. So sine of 2 theta, if I look at my formula sheet, is 2 sine of theta cosine of theta. So now I can look at my triangle and find sine of theta and cosine of theta. Well, sine, looking at this, is opposite over hypotenuse, so that's negative 3/5. Cosine of theta is adjacent over hypotenuse, which is negative 4/5. That's why it's important that you draw the triangle. And then I'm just going to take that expression, plug it right into my calculator, so 2 times negative 3/5 times negative 4/5 is 0.96, but I want it as a fraction, so I'm going to math frac it, so that's 24 over 25. And that is sine of 2 theta. Cosine of 2 theta has three options to choose from. I'm going to go ahead and do the first one, which is cosine squared minus sine squared. You could really do any of them. So cosine is my adjacent over the hypotenuse, which was negative 4/5, minus sine, which is opposite over hypotenuse, which is negative 3/5. Squared. I'm just going to type that in. Just make sure that you put negative 4/5 in parentheses before you square it. Same thing with the negative 3/5 before you square it. Gives me 0.28, which I can math frac, which is 7/25. And last but not least, I want to do tangent of 2 theta. So tangent of 2 theta is 2 tangent of theta over 1 minus tangent squared. So tangent is positive 3/4, which we actually had written over here. Don't even need to use a triangle for that one. So that is 2 times 3/4 over 1 minus 3/4 squared. Put that in my calculator. 2 times 3/4, 1 minus 3/4 squared. Math frac it gives me 24 over 7. Alright, so there's that first example using the double angle formula. Next thing we're looking at are half angle formulas. So I have sine of theta over 2 is plus or minus this expression, cosine of theta over 2 is plus or minus this expression, and then tangent of theta over 2, you have two choices to choose from. For tangent, I actually like to use this first one, just because I don't like having this expression in the denominator. So for tangent, you'll see me use the first one a lot. One thing that you need to make a note of, when you are deciding that plus or minus, the plus or minus gets determined by the quadrant. Let's make a note. By the quadrant of theta over 2. So if the quadrant of theta over 2, so if sine, actually, let me just work through an example instead of rambling over here. Okay, find the exact value of 75 degrees, cosine of 75 degrees. So 75 degrees is in the first quadrant, and in my first quadrant, all of my coordinates are positive. So that means when I use the formula, I'm going to use the plus part of my formula and not the minus. That's what I mean by the plus or minus is determined by the quadrant of theta over 2. Okay, now I want to find the exact value of 75 degrees. Well, when we were working with the unit circle and the hand trick, you never had an angle of 75 degrees. So what we want to do is we want to write this as a half angle. So this is cosine of something over 2. So I need to think of what, when I take half of it, gives me 75. Well, if I take 75 and multiply it by 2, it gives me 150. And 150 degrees is an angle measurement that we do know from the unit circle. So that means, working through my formula, I'm using the positive, and that's the square root of 1 plus cosine of 150 over 2. Now for cosine of 150, 150 is in my second quadrant. This reference angle right here is 30 degrees. So I'm going to use my hand trick. 30 degrees is my ring finger. So my ordered pair for that is root 3 over 2, comma 1/2. Since I'm in that second quadrant for 150 degrees, my x is negative, y is positive. So cosine of 150 degrees is my x-coordinate. So that's negative root 3 over 2. So I can write this as the square root of 1 minus root 3 over 2 all over 2. Now from here we do need to simplify this expression. I'm going to go ahead and work with the numerator right now. So that's a square root, and then 1, I need a common denominator, so 1 is the same thing as 2 over 2 minus root 3 over 2, and this is all over 2. So now I have, combining it, so that's 2 minus root 3 over 2, which simplifies to 2 minus root 3 all over 4. So I can go ahead and multiply these two. Okay, so I can take the square root of both the numerator and the denominator. Square root of 4 is 2, and this is your final answer. So that's the exact value of cosine of 75 degrees. Alright, now we want to find the exact value of tangent of pi over 8. So tangent doesn't have the plus or minus, so we don't really have to worry about that. But what we do need to figure out is what angle we're actually going to use. So when I take half of some angle, it gives me pi over 8. So essentially I want to take that angle and multiply it by 2. Well, if I take pi over 8 and multiply it by 2, that's pi over 4. Pi over 4, that ordered pair is root 2 over 2, root 2 over 2. Okay, so using my formula, I'm going to use the first one, so it's 1 minus cosine of pi over 4 divided by sine of pi over 4. Well, cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is also root 2 over 2. All right. So what I'm going to do is I'm going to take a different approach with simplifying this instead of what I did with the last one. The last one I would have added these two together or subtracted. Instead, what I'm going to do, since I'm dividing this fraction by this, I'm just going to multiply by the reciprocal. So this is the same thing as 1 minus root 2 over 2 times 2 over root 2, because I'm multiplying by the reciprocal of this. I'm going to go ahead and distribute. So 1 times 2 over root 2 is 2 over root 2 minus root 2 over 2 times 2 over root 2 is just 1. And then this right here, you can't have radicals in the denominator, so that becomes 2 root 2 over 2 minus 1, which is just root 2 minus 1. And there's your final answer for tangent of pi over 8. So you're just following the formulas. Again, that plus or minus will be determined by the quadrant of the original angle that you're looking at. Use your hand trick to find the ordered pairs that you're working with and then simplify accordingly. Okay. Now I'm going to find exact values of sine of theta over 2, cosine of theta over 2, and tangent of theta over 2 when I give you that cosecant is negative 5/3, and my angle is between 3 pi over 2 and 2 pi. So I'm going to use this information to draw a triangle. That puts me in the fourth quadrant. Since cosecant is negative 5/3, that means sine is negative 3/5. So here's my theta. Sine is opposite over hypotenuse. I can use the Pythagorean theorem to solve for that third side, which is 4. So now I have my three sides of the triangle, so I can find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. All right, here we go. So sine of theta over 2. Okay, now if you look at the quadrant that you are in the fourth quadrant. Your sine is negative in the fourth quadrant. Ignore what I said about sine being negative in the fourth quadrant, because that plus or minus is always determined by theta over 2. So we actually need to figure out which quadrant theta over 2 is in. So since theta is in the fourth quadrant, that means theta over 2 is in the second quadrant, because you're taking that angle and cutting it in half. So that's in the second quadrant. And in the second quadrant, your x is negative, y is positive. So when I'm looking at sine of theta over 2, I'm going to use the plus for the square root. So that is the square root of 1 minus cosine of theta over 2. Now looking at my triangle, cosine, here's my triangle, cosine is adjacent over hypotenuse, so cosine is 4/5. So that's 1 minus 4/5 over 2. I'm going to go ahead and take what's inside my radical and simplify it. So I have 1 minus 4/5, taking that answer and dividing it by 2, which gives me the square root of 1/10. So that is 1 over the square root of 10, because I take the square root of both of those. Can't have radicals in the denominator, so that's root 10 over 10. So there is sine of theta over 2. Now let's do cosine of theta over 2. Now again, my theta over 2 is in quadrant 2, which means I'm going to use a negative for my radical. And that is negative 1 plus cosine of theta over 2. So that's negative square root of 1 plus 4/5 over 2. So 1 plus 4/5 is 1.8 divided by 2 is 0.9. Fraction is negative square root of 9/10, which is negative square root of 9 is 3 over root 10, which we need to change to negative 3 root 10 over 10. So there is cosine of theta over 2. And last but not least, tangent of theta over 2 is 1 minus cosine of theta over sine of theta. So cosine is 4/5. Sine, if I look back at my triangle, is negative 3/5. Now since this doesn't have a radical, I'm going to go ahead and just put the entire thing in the calculator. So 1 minus 4/5 over negative 3/5 gives me negative 1/3. Alright, so that is using the half angle formula. The last thing we're looking at is the product to sum formulas. I do know you have a lot of formulas that you're working with, but just pay attention to the formula that you're using and have your formula sheet out while you're working. Okay, so part A says to rewrite cosine of 5x, sine of 4x as the sum or the difference. So I have cosine times sine. So cosine times sine, I'm going to go ahead and write the formula out. So that's 1/2, and then cosine times sine. So it's 1/2 sine of theta plus alpha. I'm just looking at my formula sheet right now. Minus sine of theta minus alpha. I realize your formula sheet uses thetas and alphas when this PowerPoint, oh, my PowerPoint does use thetas and alphas. Never mind. Sometimes it's using V's. Okay. So it was cosine times sine, so I looked at my product to sum formulas, looking for cosine times sine, and that's 1/2 sine of theta plus alpha minus sine of theta minus alpha. Here's your theta, here's your alpha. So we just need to plug those in. So that's 1/2 sine of theta plus alpha is 9x minus sine of 5x minus 4x is just x. And that is your answer since it's written as a sum or a difference. For the second one, I have sine times cosine, so I'm going to write down that formula that I'm using. So that's 1/2 sine times cosine. Sine times cosine is sine of theta plus alpha plus sine of theta minus alpha. So here's my theta, there's my alpha. So that is 1/2 sine of 8x plus sine of 2x. And there you go. Alright. The sum to product formulas is another set of formulas, so now you're adding or subtracting and you want to write it as a product. So now you're just using these sets of formulas. So write sine of 3x plus sine of x as a product. So I'm looking on my formula sheet for sine plus sine, and that is equal to 2 sine of theta plus alpha over 2 times cosine of theta minus alpha over 2. Just copying down what's on my formula sheet. So the 3x is my theta, the x is my alpha. And then I can just rewrite it. So that's 2. Sine of 3x plus x is 4x, divided by 2 is 2x. And then cosine of 3x minus x is 2x, divided by 2 is just x. And there you go. So that's rewriting the sum as a product. Okay, last thing is to find the exact value using the sum. So what I do want to do is I want to write this as a product. So I have cosine of 195, so this is my alpha. That's my theta. This is my alpha. Here's the formula that I'm using. So I'm adding cosine and cosine, so that's 2 cosine of theta plus alpha over 2 times cosine of theta minus alpha over 2. And double check that I'm using the right formula, otherwise it defeats the purpose. So cosine plus cosine is 2 cosine theta plus alpha over 2, cosine theta minus alpha over 2. Okay, so let's plug in what we know. So that's 195. 195 plus 105 is 300, divided by 2 is 150. And then cosine of 195 minus 105 is 90, divided by 2 is 45. Okay, so I need to find the exact value of cosine of 150. I'm going to do this in green over here. 150 is in my second quadrant. My reference angle for 150 is 30 degrees. So I'm putting down my ring finger for 30 degrees. My ordered pair is root 3 over 2, comma 1/2. Since I'm in the second quadrant, my x-coordinate is negative, which is what I'm looking for since I'm looking for cosine. So now I have 2 times negative root 3 over 2. And then 45 degrees, there's 45 degrees in the first quadrant. Putting down my middle finger, that is root 2 over 2, root 2 over 2. Cosine's my x-coordinate because that's what I'm looking for. So cosine of 45 degrees is root 2 over 2. Now 2 is the same thing as 2 over 1, so I can multiply straight across. That gives me negative 2 root 6 over 4. And that is your final answer. It also concludes your lesson for section 5.5.